Hey there, Soren. It's really nice to see you.
Good to see you. Let's just walk up here a little ways and sit under a tree and
Yeah, absolutely.
chat
It's a
a bit.
gorgeous day.
Yeah, it sure is.
It's a great day to see all of the colors on the leaves change.
Yes. And even though it's so late in the fall, it's still nice and warm, and,
True.
which is a little
Slightly
it's nice,
concerning.
but slightly concerning, absolutely. Yes, so it's gorgeous to be out this time of year. And very few people complain when it's nice weather this time of year. But
True.
in reality, it may not be that good, of course, with climate change. And the interesting thing about it, I think, is that so many people we're beginning to be concerned about climate change, but it's not easy to really experience, because weather typically in Nova Scotia is all over the place. So to see a long-term trend can be difficult.
Yeah.
And I think we humans, like if we meet a friend every day for 10 years, we don't think of them. We don't see that they're aging, right?
Yeah.
But if we don't see a friend in 10 years and then see them, holy shit, you've gotten quite old. haven't you?
Absolutely, yeah.
Right? So I think our human perception of change is not all that good, actually.
Yeah.
When we see something every day. And climate change, of course, is something that's up and down, so therefore it can be difficult, I think, to really to notice it. Even though certainly, like when you talk to some people, they'll say, well, I remember, back in 1980 it was such and such a weather, right? But it certainly is something we should really be concerned about.
Yeah.
And what's the solution? Sure, reducing carbon is the obvious thing that we have to do, but it's not just climate change that we're facing. I think right now we're facing a whole whack of different, what you might call epidemics. So we recently had the COVID epidemic, so infectious diseases, and they're going to be increasing. There's climate change, there's loss of species, loss of habitat, social inequity. Lots of things are happening, and I'm not so sure we can tackle just one of them. I think we need to look at all of them and try to understand what in the world is that's going on.
I think looking at them as a whole is sort of the way we move forward through these things, because by tackling one, we start to tackle them all, right?
Yes. But I don't know that we humans are very good at tackling
big picture
seeing, and even small things. I often think of, I remember my water tap in the kitchen was dripping, so I just tightened it a bit more, right? And then it dripped again, and I tightened it even more, and when I tightened it so hard that the thing fell off and water was everywhere, that's when I fixed it.
Fair enough.
And so it's so human nature is a funny thing, and it's why is it that we think a certain way? Is it natural to have certain tendencies, or is this something that we're just grown up with? So kind of a what can we call it? A way of seeing the world that we think is the correct way of seeing it, but there are many different ways of seeing the world.
Yeah, so many different worldviews out there.
And so many different worldviews, and that's a difficult one to tackle.
Why don't we just take a walk down this little path? This looks nice here.
Sure.
So my understanding of worldviews is how we put ourselves in the grand scheme of things, basically, like how humans see ourselves in nature and in the system that exists. Is that sort of what a worldview would be?
Yes, it also relates to our value systems.
Okay.
And it tells us, where we came from, our place in nature, and what happens after death. So the worldview that had kind of spread across Europe was the Christian worldview. Starting approximately in the late 1600s, intellectuals, philosophers began to be unhappy with that kind of a fatalistic perspective. So people like Galileo, Descartes, Newton, Bacon, Locke and More were the kind of architects of this emerging worldview that we now call the mechanical worldview. Why don't we go down to the lake again and just sit on a log and kind of take in the view of the area?
Sure, sounds great. That's a beautiful body of water.
Yeah, yes.
And Newton he was using mathematics to describe the world, right? Like he was the guy where the apple fell on his head and he just sort of had the brilliant idea of gravity all of a sudden, but
yes.
he started to really break down the world into math, right? And he was the one that figured out we can use math to predict tides and moons and all of those sorts of things, and started to really shift us a little bit more to a mechanical worldview, would you say?
Yeah, that's correct. Descartes actually said that mathematics would be the tool for understanding nature, the universe. And it was Newton who really put that into practice.
Oh, okay.
So Newton basically saw the world, nature, as a giant machine made up of parts that could be understood using mathematics. So in other words, the machine consisted of entities, you could say mathematical equations that could be put together to understand how the whole thing works.
Okay, so instead of looking at the machine and looking at it as a whole, they were trying to break it down into smaller sections and understanding those.
Yeah, and then by understanding those ones, you just put them together and then you'd understand the whole.
Okay.
And that never worked in ecology, especially, but it certainly doesn't work in anything.
Why don't we just take a walk down this little path? This looks nice here.
Sure. Okay, so this machine analogy that was beginning to take place was really one where we humans stepped outside of nature and looked in and thought that we could understand the parts of this machine and we could manipulate it to our benefit. So Descartes, his famous thing, I think, therefore I am.
Right.
So that separated the head from the body in essence. And this really separated humans from nature. In other words, we stepped outside of nature and could look in. Bacon is very central in this because he's fundamentally the person who, let's say, invented science. He did not like the Greek deductive reasoning that had dominated for a long time. He wanted to understand nature by making observations and set up experiments and test them to see if the understanding was correct. And Bacon, in fact, is the one who argued that resources in nature, the parts of nature, should be used by us humans for our benefit. So Bacon is the one who really, indirectly stated that we humans should subjugate nature for our benefit. People started to looking at everything in terms of parts. So the human body is made up of parts, like hearts and lungs and liver and blah, blah, blah. But you can't understand one part in isolation of the whole, right? So understanding the different parts of the human body does not mean you'll understand how the whole body works. So from the perspective of the mechanical worldview, ecosystems basically consist of just a whole bunch of species, and if you understand what the individuals are doing, you can't put them together to understand the dynamics of an ecosystem, because there are what we call emergent properties, which are the properties that are not predictable based on the individual actions.
Right.
So the mechanical worldview is the notion that everything is a machine and all we need to do is understand the parts.
So Western languages seem to be really heavily noun-based. Do you think that's a result of the mechanical worldview?
Yeah, I do, because if you look at something as consisting of parts, then you have to name the parts so that you know what you're talking about. In naming them, we often feel that that's all we need to do. Like, well, if we have a name for something, that's it. Let's sit down on the log here for a while.
Yeah, this looks like a great spot.
And continue our discussion.
Yeah.
So yes, so Western languages are heavily noun-based, but in naming them, we often put things into boxes.
Right.
That don't exist.
Yeah.
We create the boxes.
If we make the boxes, we can put the things in the boxes.
Exactly.
Right.
So a good example, I think, of us putting things in boxes that really are artificial is color. So the light from the sun, of course, the wavelengths is a continuum of different wavelengths. And part of it is we call the visible spectrum. That's what we can see. And in that visible spectrum, there are different colors, which is a function of the wavelengths. So we talk about red and yellow and green and blue, etc., as if they exist. And in some sense, they do exist. But it's a continuum of different wavelengths. So an example of a continuum in ecology would be biomes. So we define, tropical rainforests and savannas and deserts and hardwood forests and the boreal forest as if these are discrete entities. And indeed, if you're standing in the middle of them, yes, in a sense they are. But if you were to travel, say, from the equator to the North Pole, it would be a transition, and it would be very difficult to say, okay, here's the line between a tropical rainforest and a savanna, or a savanna and a desert, etc., etc. So in treating them as distinct entities, I think we get the wrong impression that, in fact, it's a gradation. And ecologists obviously know this very well, but I think, again, it's back to the general public may not have that understanding and therefore have a more simplistic way of seeing the world. So if we ask questions about color or biomes as if they are discrete entities, we may very well get the wrong answer. Maybe it doesn't matter in some situations, but if we're interested in understanding the processes that are taking place, then we need to treat things as a continuum rather than as discrete.
And so then that just became the codification of language, where we decided that things are going to be this and that, and sort of removing it from its initial.
Yes, and this is so fascinating. I think that indigenous languages around the world basically are verb-based. So their language, it's all relational and interactions that happen.
Okay.
Where in the noun-based, in our society, it's not interaction because we name things and they're separate.
There's no relationship between
them. So there's
no
relationship between them. Exactly.
But in terms of the mechanical worldview, we must have moved away from that sort of simplistic parts or segment thinking, right?
Yeah. Physicists have adopted the quantum physics, where everything is basically energy. So there is no smallest particle. It's just energy. And in biology, we talk about ecosystem as being complex adaptive systems impacted by chaos and being far away from equilibrium. And an area that's emerging is systems thinking, which is a holistic way of looking at ecosystems. So yes, we certainly are moving away from that original, very simplistic mechanical worldview. However, as a society, I think we are still living in the mechanical worldview. We still see ourselves as being outside of nature. We still see nature as supplying us with resources for us to use. And we still think that we can totally predict how nature is going to operate. And I think over short terms, maybe we can, but not necessarily long term. Meteorologists are very good at predicting what the weather's going to be tomorrow, but ask them what it's going to be like in a week, and they're not so good at it. So yes, I think we have moved beyond the mechanical worldview, yet mentally we still live within the mechanical worldview.
Mm-hmm. So how does this mechanical worldview fit in with climate change? Like, where does climate change, how does it interact or work with this modern mechanical worldview?
Yeah. Well, I think climate change is a consequence of the mechanical worldview, because with the mechanical worldview we have applied science to understand how we can control, how we can attempt to control nature. And a large component of controlling nature, in fact, comes from our heavy dependence on energy. Burning fossil fuels for all our various machines that, subjugate nature, from big harvesters cutting down forests to tractors plowing fields to us human driving cars, etc., etc. That's where all the CO2 comes from. That's elevating the temperature. And the interesting thing is, I think that fossil fuel engineers, scientists, they knew a long time ago that CO2 would increase, but kept it secret. And this is the problem with applied science, is that the scientists working for corporations that discover things cannot be replicated by independent scientists because it's all secret and patented and you name it. So climate change is very much a consequence of our mechanical worldview.
So you had said that a noun-based language had come from this mechanical worldview, but you had also said that some indigenous languages are verb-based. Did that stem from a different worldview? Is that where that came from?
Yeah, so indigenous cultures generally see themselves as living within nature, as being part of nature, as being related to all the other organisms, and that is reflected in their language, and it also means that they're not out to control nature like. And I think that's just so fascinating.
Have like a mechanical worldview that is, more aligned with the pure hard science, and then a holistic worldview that's coming from a more indigenous rooted culture. And as people start to move through the world, they begin to hold both.
That's the hope, I think, especially with this concept of two-eyed seeing that Elder Albert Marshall has developed over the years. Two-eyed seeing, which is seeing the world through science eyes and seeing the world through indigenous eyes. Science is one way of understanding what's happening around us, but it's not the only way, and it's limited in its understanding. Pure science is when individuals just interested in understanding something and have no economic motivation behind it. So applied science is the science that is used to subjugate nature.
So do you think that by beginning to hold these two worldviews, it makes people uncomfortable?
The minute you step outside of a worldview, of the worldview that people have lived in but don't question, they become uncomfortable because it's into uncharted territory in a sense, right?
Yeah.
It's the unfamiliar. It's scary. At the political level, there's definitely they're uncomfortable, partly because it's our economic system is what's driving the society, where and that's a whole other, like, that's part and parcel of the mechanical worldview, because our economic system comes out of the mechanical worldview, which is based on profit and capitalism, etc. So I found it interesting when Charles Darwin published his famous book Origin of Species. He did not talk about survival of the fittest, which is often the term that people think of when they hear about evolution. Charles Darwin, an economist, biologist, philosopher at the time, Herbert Spencer, he coined the term survival of the fittest. And he coined it because he saw the parallel between evolution and our economic system. Now, politics seems to be subservient to our economic system. So even though lots of people are not satisfied with the mechanical worldview, I think it's still at the level of our economic system and political system. That's the status quo, and don't rock the boat. So even though things are changing, we are slowly moving, hopefully, out of the mechanical worldview. It still dominates our society. And that's why I think we need interim solutions to problems. So in terms of climate change, yes, we do need to reduce CO2, absolutely. And maybe some carbon capture technology is good as an interim solution. So we don't get to the situation that'll be catastrophic. So I think in the interim, a mechanical solution may be okay, but in the long term, it's not going to be the solution.
Do you think that there's one pathway forward, but both need to be held as we go forward? In the interim, while the mechanical worldview is so ingrained, that might be how we take our first step forward, but knowing we are part of nature, not separate from nature.
So the concept of Elder Albert Marshall's two-eyed seeing really helps us to blend those two worldviews together and allow us to see it in a more holistic fashion, right?
Through indigenous eyes, it's not a new one. So it's just a matter of realizing that, yes, in the past, that system, that way of seeing was sustainable. Good heavens, the Mi'kmaq have been in Nova Scotia or in the Maritimes, for over 10,000 years, living sustainably. The mechanical worldview started in late 1600s, 1700s, so it's only been around for 400 years, but it's already showing that we're not sustainable. So let's wake up and realize that maybe there's something in the indigenous worldview. And the other thing, of course, is that the mechanical worldview has given us all kinds of creature comforts. There's no doubt about that. In terms of, unfortunately, mostly people in the Western world, being able to fight disease, drive cars, live in houses where the temperature is controlled summer and winter, and all kinds of, benefits that unfortunately not equitably distributed around the world. But this has come at a huge environmental cost, from the increased CO2 in the atmosphere to pollution, you name it. So walking through this forest here, we can choose to see the different species of trees and shrubs and etc. as parts of the forest, as separate entities, where we humans are outside, so we're looking into the forest, or we can choose to see the forest as something that we are a part of, where in fact we're all interconnected. We now know that trees are interconnected underground via mycorrhizal networks, where they in fact share energy and information. The Mi'kmaq have a wonderful understanding of forests, where they see the trees holding hands underneath the ground through the intertwining of their root system. So they are supporting each other instead of just being, individuals standing there.
Right, so they're connected. It goes back to that connection portion, that verb versus noun
Yes, exactly.
part of the language.
Yes.
That's really cool.